So thus far into calculus, we've been differentiating functions where they've already been isolated for y. So it's been relatively easy because we haven't had to isolate for y. It's just been, y equals 3x squared. Differentiate this. Well, we use the power rule. It's going to be 6x. Or differentiate y equals sine of 2x. Well, we know we have to use a chain rule, right? We're gonna have to do cosine of 2x because we know that the derivative of sine is cosine, but we also have to multiply by the inside, which is 2. So this is going to be 2 cos 2x, right? We have like these little strategies, but that only works when everything's already isolated for y. So what happens when we try to differentiate something like y squared equals x, right? How could we differentiate and maybe find the slope of the graph when x was equal to 4? Well, the first problem that comes up is that x is equal to 4. That's right here. Hold on, let me just make this a little better. X is equal to 4 right there. That's what the tangent would be. And also right here. So there's going to be two tangent points, right? Because x is equal to 4 right here. And there's 2 points on the graph for y that are going to give you two different values. So how could we find both of those? Well, when we differentiate something like x, so d by dx of x, right? We know that this is just going to be 1. But there's an imaginary times x prime in there. Because when we use the chain rule, right, we know that this is just 1, but we also have to multiply by the derivative of the inside when we use a chain rule. So it's really 1 times the derivative of x, right? And that's just going to be 1. So it's just 1 times 1. But when we're doing something like this with the y squared, if we take the derivative of y squared with respect to x, right, d over dx, the right side obviously is just going to be 1, right? Because we know the derivative with respect to x of x is just 1. It's just dx over dx. But how can we possibly take the derivative of y squared, an expression in terms of y, with respect to x? Well, we don't know what the derivative of y squared is going to be. So what we have to do is use the power rule and treat it like it's x. So it's going to be 2 times y, but we have to multiply it by the derivative of itself, because that's what the chain rule really is. We're taking this quantity y and we're squaring it. So y is our inside. So it's going to be 2 times y prime. So what y prime really is, if we divide by 2y on both sides, it's 1 over 2y. And what's y in our original equation? Well, if we square root both sides, it's just going to be plus or minus the square root of x. So this is really plus or minus 1 over 2 times the square root of x. This is what's going to give you the slope. So if we're trying to find the slope when x is 4, all we do is plug in 4 for x. So it's going to be 1 over, or plus or minus 1 over 2 times the square root of 4, or in other words, 2 times 2, or just 4. So plus or minus a quarter is going to be your slope when x is 4, and that makes sense because when, like, every 4 units we move over, we're going to move up 1, and same with the other one there. So that's how we could implicitly differentiate y squared equals x. That's what implicit differentiation is taking something that's not a function, or taking something with y's and x's everywhere, and figuring out what y prime is. Okay, so let's do an example here. Find the slope of the graph of yx squared minus y equals 3x plus y squared when x is equal to 0. Well, y times x squared, what's the derivative of that? Excuse me, I'm just getting over this nasty cough here. So this means we're going to differentiate everything with respect to x. The yx squared, the negative y, the 3x, and the x squared. So the derivative of y times x squared with respect to x, that's just going to be 2xy, because we're treating that y like it's a constant, a coefficient in front of the x squared. Then we have minus, what's the derivative of y? Well, we're just going to write y prime, because we don't know what it is. That's going to equal the derivative with respect to x of 3x, which is 3, plus the derivative of y squared with respect to x. That's just going to be 2y times y prime. That's what we just talked about above. So what we're really trying to solve for with implicit is y prime. So let's add y prime on both sides. And let's get rid of this 3. Let's subtract it on both sides. So we get 2xy minus 3 equals 2y times y prime plus y prime. So if we want to solve for y prime, we can factor out y prime. And it's going to be y prime times 2y plus 1. Get rid of this 2y plus 1 by dividing it on both sides. Right, that's going to cancel. So y prime is going to be 2xy minus 3 over 2y plus 1. So they want us to figure out what the slope of this thing is when x is 0. Well, let's think about it. When x is 0, what's this whole thing going to be? We can plug in 0 wherever we see x, so right there and right there. So it's going to be y times 0 squared is 0, so it's going to be negative y equals 3 times 0 is 0, so negative y equals x or y squared. And just like when we had x squareds, right? When we were factoring quadratics, we wanted everything to be on one side, so the other side was equal to 0. So if we added y on both sides, we would get 0 equals y squared plus y. And factoring this, we get y times y plus 1. So just like if these were x's, 0 equals y times y plus 1. So these two things multiplying into each other, those are going to go as 0. So either y equals 0 or y plus 1 equals 0. Therefore, y is equal to negative 1. So there's going to be two cases that we can work with here. Either y is 0 when x is 0, or y is negative 1 when x is 0. So for y prime, let's just try x is 0 and y is 0. So this is going to be 2 times 0 minus 3 over 2 times 0 minus 3 plus 1. Or sorry, not minus 3. 2 times 0 plus 1. These terms are going to go away, and that's just going to be negative 3 over 1, so negative 3. Okay, what if we were doing y prime 2xy minus 3 over 2y plus 1? What if we were doing the point 0 and negative 1? So that's going to be 2 times 0 times negative 1. That's going to be 0 as well. Minus 3 over 2 times negative 1, right? That's our y plus 1. So this term's going to go away. 2 times negative 1 is negative 2, plus 1 is negative 1. So it's going to be negative 3 over negative 1, which is positive 3. So these are our two slopes. And if we look at it on a graph, we can see that this is the graph of our relation. And we can see that at x equals 0, y is going to be 0 and negative 1. So if we were to plot, let's say y equals, our slope was negative 3 for one of them, so negative 3x. And let's say y equals 3x, 3x, and we have to subtract 1. Okay, it's going to be tangent to this x equals 0 perfectly, because when our slope was negative 3. And similarly, our slope being positive 3 at the coordinate 0 and negative 1, that also works. So we can see by implicit differentiation that this is the correct method to use, and we can figure out what these slopes are going to be, even though it's not a real function. Okay, so that's how we would do that question. Last one, find the slope of the graph of sine squared x over e to the x equals y cubed plus y. So we're going to have to differentiate sine squared x over e to the x, and that's going to be equal to the derivative with respect to x of y cubed plus the derivative with respect to x of y. Okay, so since we're taking the derivative of a quotient, we're going to have to use the quotient rule on this one. So remember the quotient rule, if we had u over v and we're taking the derivative of that, it's going to be v times u prime minus u times v prime over v squared. So v in this case is e to the x because it's on the bottom, and u prime is going to be the derivative of sine squared of x. So the derivative of sine squared is really, sine squared x. When we say sine squared x, we really just mean sine of x, all of that being squared. So this is the derivative or sorry, if we use the chain rule, right, we can consider sine x our inside. So we can use the power rule, bring this 2 out front. It's going to be 2 sine x, and we have to multiply by the derivative of the inside, which is just the derivative of sine x in this case. So it's 2 sine x times the derivative of sine x, which is cos x. So 2 sine x cos x, and you'll realize this is a identity, right? We can just say sine of 2x. Those are equivalent. So this is going to be v times u prime. V is e to the x. U prime is sine 2x minus u is sine squared x. V prime, that's just the derivative of e to the x, which is itself e to the x. Pardon me, over e to the x squared, right? And that's the same as just e to the 2x. And you'll realize that every term in this expression has an e to the x, so we can cancel that out, cancel the square. And what we're left with is sine 2x minus sine squared x over e to the x. So that's the derivative of the left side. That's how we can do that. So now that we have that figured out, we can write that for our left side. So it's sine 2x minus sine squared x over e to the x. So that's going to equal, we can use our power rule for y cubed. So it's going to be 3y squared. And remember, we have to tack on this y prime because we don't know what y actually is, plus the derivative with respect to y, or with respect to x of y. So that's just going to be y prime. So we can factor out a y prime for this one on the right side. So it's going to be y prime times 3y squared plus 1. Divide that on both sides. So y prime is going to be sine 2x minus sine squared x over e to the x times 3y squared plus 1. Okay, so this is our expression for the derivative with respect to x of y. So they gave us the coordinate right here, -4 and 3.045. So we're just going to plug that in where we see x and y. So sine times 2 times -4, sine of 2 times -4, minus sine of -4, all that squared, over e to the -4 times 3 times 3.045 squared, right? Just plugging in x and y. So this is sine of -8 minus sine of -4 squared. So let me just put that in my calculator here. That's going to be negative 1.746. Okay, and then we got e to the -4 times 3 times 3.045 squared plus 1. So what we get there is 0.5277 for the bottom. Let's put that in our calculator. And that's going to give us negative 3.31, sorry. So this is going to be the slope of this relation at the coordinate -4 and 3.045. So sorry if I kind of rushed through it. This video, the program I've been using has been kind of weird in terms of saving the video. So I'm kind of going a little bit quicker this time, but I hope that made sense. Implicit differentiation is just differentiating functions that aren't already in terms of just y equals something. It's when the y's and the y squareds are kind of embedded in a random jumble, a big mess. So I hope this helped, and I'll see you in my next video.